So now we're going to talk about the feasibility analysis. This is where we're assessing different alternatives. So the feasibility analysis, generally what we want to do, if we're thinking about doing a project, a lot of times we're going to, we're going to identify this project and we're going to have a good idea of what we can do or what this project is going to look like. Now that could look like a custom developed solution. It could look like something we outsource. It could be something we purchase off the shelf. We might be looking at a couple different purchase off the shelf options, but we're going to come up with, these. And again, we can look back to the sources of software if you're looking for some inspiration on what these alternatives would be in an IS systems project. You can go back to the sources of software, and some combination of those sources would be our different alternatives to meet this need. And one thing we want to make sure happens is that if somebody's initiating a project, they should not just be telling you we are going to buy this software to solve this problem. What should be happening, and management, of course, would be looking for this, and an auditor should be looking for this. What are the alternatives that were considered to make sure that the one that you chose was the best option? So what were the alternatives you looked at? And you should be comparing these different alternatives. And each one of them, you should be doing a feasibility study. So you should be doing a feasibility study that looks each one of these alternatives and tries to determine which one of them is the best or most appropriate. Now, sometimes you might discover that what you thought was the best option because, of your understanding of how things are going to work. When you look at the objective facts, after you do the feasibility analysis and you look at it objectively, you may come to the conclusion that, I was wrong. Really, this other way is the better way to do this project, or this other alternative actually seems like it might be a better option. Maybe a vendor presents you with some new information that you hadn't considered and say, oh, we didn't even think about that. Maybe the cloud is a better solution for us. Maybe you do your feasibility analysis and discover that the cloud is going to be a lot less expensive, right? So let's take a look at this. So a couple different types of feasibility you're going to look at. Economic is the first one I'm going to cover. That deals with basically, what is the economic impact? What is the cost and the benefit economically? The money, finance, right? Or some people call that a financial feasibility analysis. I think I usually use that term over economic, but the textbook from which I'm basing this presentation on, which is Valachik and George's Modern Systems Analysis and Design, 8th edition, uses the term economic feasibility analysis, but again, I usually call it financial feasibility analysis. Then you have a technical feasibility analysis, which basically answers the question, can we do this? Does the technology exist? Operational, should we do it? Scheduling, do we have the ability to fit this into our schedule? Do we have the resources to cover this? Are there any legal or contractual issues with doing this? Is there any political reason we shouldn't do this? And I'll talk about these as we go through these slides, but let's start with the financial feasibility analysis. So in the financial feasibility analysis, we are going to try to determine if or which of our alternatives is the most financially feasible. So an economic feasibility is the process of identifying the financial benefits and costs that are associated with the development project. So this may also be called a cost-benefit analysis, or somebody might use something about return on investment, which I'm going to talk about that term later on. So the project is reviewed after each phase to decide whether to continue, redirect, or kill a project based on the economic feasibility. So this is one of those stop points. When we do a no-go or no-go. When you saw my very first slide presentation, I showed you that spiral. And in that spiral, there was this no-go or no-go axis along that spiral where we would stop and reevaluate what we're doing and make sure that we're moving in the right direction. The economic feasibility analysis or financial feasibility or cost-benefit analysis is an important part of that decision to make sure that we go forward. Just like when I was talking about fixing my car, and when I'm fixing the car myself, I should probably do an economic feasibility after I've spent a certain amount of money to say, should I keep going, or am I going to go broke trying to fix this thing without just getting a mechanic to do it for a fraction of the price? So we're going to talk about tangible benefits are basically anything that we can measure in dollars, right? So if we can a tangible benefit, so tangible means something that you can touch and feel, right? That's tangible. So anything that we can measure, that's how, I guess, a good way to remember it. Anything that you can measure in dollars is going to be a tangible benefit. So examples might be reduced expenses, lower transaction costs, higher profit margins. So either money that you're going to make or money that you're going to save that you can enumerate, that you can calculate would be a tangible benefit. So most tangible benefits will fit into one of these categories. Either it's going to be a cost reduction or a cost avoidance. It could be error reduction, which again could be tied back to a cost. Increased flexibility, which also could be tied to a real dollar amount, a real dollar cost. Increased speed or activity, which is going to make us more money, more efficiency, right? Improved management of planning and control, or opening up new markets, or increasing sales or opportunities. These would all be a financial or economic benefit. All right, so uh, the intangible benefits are benefits that are derived from the creation of an information system that cannot be easily measured in dollars or with any degree of certainty. So how it may have a direct organizational benefit, such as the improvement of employee morale. That's a classic example of an intangible benefit. People are happier. That's a benefit. People are not happy. That's a cost, right? So that's one example. May have a broader societal implications, maybe reduction of waste, better resource consumption. For example, a lot of department stores now put solar panels on the roof. There's a cost to doing that, but what's the benefit? Well, I mean, the benefit is that you're a better economic or a better environmental citizen. But is there any benefit to doing that economically? Maybe not 10 years ago. Today, I guess you probably could make the argument that there is. But years ago, people did it because of image, right? They wanted to, they wanted to portray that they were better for the environment, And I guess eventually you could wrap a dollar around that. So, maybe that could be tangible to some extent. But the long and short of it is that intangible benefits are things that you really can't measure. And here's an example from, again, this is from Valachik and George's Modern Systems Analysis and Design, 8th edition, where they enumerate various examples of intangible benefits in Table 5.3. So it's going to be in Chapter 5 of Modern Systems Analysis and Design. This is a pretty good list of some things that that might qualify as an intangible benefit. And again, you really can't put this on a financial chart because there's no number to wrap around it, but it's certainly something we need to take into account, and we can do that when we do our objective, when we make our objective decision. This is one of the factors that we can consider. So we also have tangible costs, which are going to be costs that are associated. So we have benefits, but there's going to be costs as well, right? We have to buy something to get these tangible benefits, right? So there's going to be some expenses that we're going to incur. That could be hardware costs, labor costs, operational costs like training and building renovations if you have to make room for a new data center or something like that. So again, we have to try to make sure that we cover as many of these tangible costs as we can. This is one of the harder parts is how thorough you have to be with this financial analysis. You don't want to miss large dollar items, right? Something as simple as putting in a new system maybe is going to require the addition of 40 servers in a data center. And you calculate the cost of those 40 servers, and you calculate the service agreements and the out-year costs and so forth, which we'll talk about in a minute. And then finally, you put this whole, and maybe you're really close to the line on your financial feasibility, but it's just barely enough that you're going to squeeze by. So you go ahead and do the project, but then you find out you're spending a lot more than you thought because you forgot about the air conditioners, right? 40 machines generate a tremendous amount of heat, which is going to increase the electric bill on the air conditioners for the data center. So there's a tangible cost there that's very easy to miss. So again, this is where that experience comes in. A lot of experience with this stuff. So one of the things that we want to look for with in the determination of project costs is to make sure that all of the items were thoroughly examined. And certainly something we can learn from looking at past projects, tangible cost calculations, is what did they miss, right? We can use that to inform us as to what might be important to include in future projects, or what we should be seeing in future projects when they do a financial feasibility analysis. All right, so an intangible cost is a cost associated that cannot be easily measured in terms of dollars. So that could be things like loss of customer goodwill, employee morale could go down, operational inefficiency, right? So these are things we want to try to consider. A one-time cost is a cost associated with the project startup or development of the system. So this is something we pay up front, right? So it's going to be a one-time cost. This could be things like systems development that we pay for up front, new hardware and software, user training, which happens in the beginning, site preparation, data or system conversion. This is probably one of the challenging things a lot of people forget about is converting. A lot of times if we're replacing a system, we have to convert all of our data from the old system to the new system. And we get burned by this in healthcare all the time. Perfect example in healthcare is, you have a hospital that has an electronic medical record system, and every patient in that hospital is identified with some unique identifier in that system. But when you implement a new system, all those patients have to get new identifiers. So now you have to migrate all of the old patient records to the new patient system, and all of their identifiers have to get modified as that happens. And that can be a challenge, right? If you have a million patients and you have to, match all this, and by the way, you can't get it wrong, right? If you get that wrong, that could have pretty serious implications down the road, and certainly could open us up to a lot of risk. So that's certainly a cost that we would incur to making sure that that's done right. So a recurring cost is a cost that is resulting from the ongoing evaluation and use of a system. So we're going to incur a cost over time. So examples of these could be maintenance fees, support fees, for example. Data storage expenses. If you're using the cloud, right, you have to account for that data storage over time. Incremental communications, new software and hardware leases, supplies, expenses, forms, and so forth and so on. So we could use some kind of worksheet. And again, this is from the Pine Valley Furniture example in Modern Systems Analysis and Design, 8th edition by Valachik and George. So they use this example as a worksheet for calculating one-time costs, as well as recurring costs. And again, you can use some of the examples here to brainstorm what those might be in a project. And once again, this is where that experience probably comes into play, right? Having that background and experience to do this. So both one-time and recurring costs can consist of multiple items that are fixed or variable. So fixed costs are billed or incurred at a regular interval and usually at a fixed rate. So that's going to be a fixed cost. And then we have, so example, facility lease payments, would be an example of a fixed cost. A variable cost is items that vary in relation to usage. So like long distance charges, good grief. This is another place that modern systems analysis and design kind of dates itself as not being so modern because nobody pays long distance charges anymore, right? I imagine that a lot of students probably have never even seen long distance charges on an actual telephone bill. But that's, I guess, could be an example. Better example might be your electric bill, right? So your electric bill or your cell phone bill. If you have a cell phone bill, you would say that your cell phone bill is a fixed cost because you pay the same monthly fee, but it could be variable if you go over your fixed amount, right? So something to be aware of. But that's something you could try to account for in a feasibility if you were, say, comparing different carriers, at the same level, for example. All right, so once we brainstorm all of these costs and these benefits, right? So now we have a good idea of what our upfront costs are going to be, what our recurring costs are going to be over time, and we try to account for a lot of this stuff. Then we're also going to try to get all of our benefits figured out. How much extra are we going to make because of efficiencies we add to the process and so forth. And again, this is all for tangible stuff at this point. The intangible things we can weigh those factors later on, and I'll talk about that probably in a different video. But once we have all these tangible factors, then one thing we have to think about is the time value of money. We can't just simply take the recurring costs over time and add them up for 5 years, right? Because if I'm paying $50 a month right now, there's a good chance I'm going to be paying more than that in the future. And likewise, if I have a benefit right now of a certain amount, that benefit is going to be reduced over time and we have to use a discount rate to do that. Why do we have a time value of money? Best example I can come up with you is selling a car, right? If I wanted to sell you my car, and let's say I have this old Jeep Cherokee, right? I have a 2000 Jeep Cherokee. That's my car. It's kind of old. I mean, it's almost 20 years old, this car, but I love it. I'm never going to sell it. But let's assume that I wanted to sell this old Jeep. I could probably get $2,000 for that, I think. So let's say I put it on Craigslist for $2,000, right? And some guy comes to my house and looks at it and he says, "Listen, I'll give you $1,800 for it today." Right? Or I'll come back next week with the full 2,000 and I'll just give you the $2,000 in a week. I won't have all the money until next week, but I got 1,800 with me right now And if you can take that, I'll take the car off your hands. I think if I asked you, most of you would probably take the $1,800 instead of waiting a week to get to 2,000. Money in my hand today is more valuable to me than money in the future, right? And if you think about it, that makes sense. If I have more money today, I can earn interest on it, right? Now, in my example, I'm not going to earn $200 in a week in that example, but that $1,800 is still more valuable to me today because what if he doesn't show up next week? He's standing in front of me right now. He has the money right now. I don't know. There's some uncertainty as to whether or not he's going to be here next week. So I think intuitively, all of us understand that there is a time value to money beyond just the interest one might earn on that money. So time value of money is more than just the interest or the depreciation over time. It's also the value of having it in your hand right now. So we basically capture that time value of money by using a discount rate. So this is something accountants use to calculate the value of something in the future. They use that discount rate. So a present value is the current value of future cash flow. In other words, what in order for us to compare apples to apples in a financial feasibility, I have to take all of the money I might make in the future and I have to calculate its present value to me right now so that I can compare these different alternatives, so that I can compare to see if this is worth it to me right now. So the net present value is basically when we use the discount rate to determine the present value of cash outlays and receipts for everything, right? So basically, we're going to take all of our tangible benefits and costs, recurring and one time. We're going to add them all up with their net present values for each of those years. We're going to add them all up. We're going to aggregate them, and that's going to give us the net present value. The net present value is considers both the costs and the benefits. Hopefully, our net present value is positive, meaning that we're going to, in 5 years or 10 years, we've made money. We're not losing money, right? And if you're losing money, that's certainly something we need to know about, right? And an ROI, or a return on investment, is a calculation that we do that tells us what level of relatively speaking, what are our earnings going to be, right? That's what an ROI tells us. ROI is a single number that sort of encapsulates all of the other things I talked about. So we take the time value of money, we calculate the net present value over time, the present value and then the net present value for the entire project. We compare the ratio of our costs and our benefits, and that gives us an ROI. A positive ROI means that we made money. A negative ROI means that we lost money. Now, when you're comparing different alternatives, there are many cases where all of your ROIs are positive. That's pretty common, right? So the idea is that with all of these alternatives, we're going to be eventually making money, but which one is the better ROI? Now, I've also worked on projects where all of the alternatives have a negative ROI. No matter what I do, I'm going to be losing money. I have to do this project, maybe for regulatory reasons, maybe just for patient care reasons if I'm a hospital. For some reason, I have to do this project. It's been decided that this is something we need to do, but I can't really wrap any real good value around this from an ROI perspective. So at that point, I might just be trying to determine which one of these is the best of the worst options, right? Which one of these has the least negative ROI. So that's the other way you look at this. One other piece you could look at is the break-even analysis, or the BEA. That's going to tell us at what point in time is our cumulative cash flow equal to our ongoing investment. In other words, at what point in time have we both invested and have received the same amount of money? So at what point have we broken even? So that would be the break-even analysis, or the BEA. So the equation for the time value of money is, as you see here, PVN equals Y times 1 over 1 plus I to the nth power, right? Everyone's probably saying, gosh, Brian, I didn't think this was a math course, right? But this is really just basic arithmetic, right? Nothing too complicated here. PVN is the present value of Y dollars end years from now based on a discount rate of I. So you can see I underneath the 1 there, the inverse there. So again, PVN is the present value of Y dollars N years from now based on a discount rate of I. So that's what you fill in for those variables for Y, I, and N. Y is going to be dollars, N is going to be the number of years, and I is going to be our discount rate, usually as a percentage. So it would be something like 0.12 for a 12% discount rate, which seems to be pretty common these days. The NPV is the sum of PVs across all years, the net present value, and calculates the time value of money. So I have a spreadsheet that you can use to do this, which I'm going to show you in a different video. So I'll kind of review how to use that spreadsheet and how we come to these conclusions here later on. So a break-even analysis is a type of cost-benefit analysis to identify at what point, if ever, the benefits are going to equal the costs. And this is the this is going to be the equation for the break-even ratio, a little bit simpler than the previous one. You're going to take the yearly net present value cash flow minus the overall net present value cash flow and divide that by the yearly cash flow. So not too complicated, but really the end game is to try to get to a spreadsheet that looks like this. This is from Modern Systems Analysis and Design by Valachik and George, 8th edition. In chapter 5, I believe it is, they have this picture of a spreadsheet. So I have a copy of a spreadsheet that works kind of the same way as this one. Mine's obviously a little bit different, but I have one that you can use to try to calculate the net present value and get the ROI and the break-even. And I'll give you a copy of that. The only problem is mine is fixed at 5 years. There's probably better ones that you can use to extend that past 5 years, but mine's a good starting place. You can start with mine. So there's just a pictorial of from the same textbook, Modern Systems Analysis and Design, 8th edition, Valachik and George, where it shows the what the break-even point looks like in a visualized graph. So once we finish the economic or financial feasibility analysis, the next step is to look at the technical feasibility. This is a lot easier, right? For us in the technology world, financial stuff can be kind of cryptic, right? But technical feasibility is pretty straightforward. This is the process of assessing whether or not whether or not the goals are attainable for this particular project. So, do we have the hardware necessary, the software, the operating environment, the size, complexity, the group's experience with similar systems with this technology? For example, I might have 3 alternatives. One of them uses Microsoft SQL Server as its database engine. The other one might be using Oracle as its database engine, and the other one might be using Couch, which is a hierarchical database management system, sort of a NoSQL type database. Well, my team might be very well versed and understands Microsoft SQL Server. They've gone through training. They understand it. Maybe they know Oracle a little bit because there's some similarities there, but it's not directly in their wheelhouse. And finally, they maybe they don't really know anything about Couch, even though it's a great database engine. They might not have a lot of familiarity with it. It's a relatively new technology, Mongo Couch, NoSQL, things like that. So in that case, I would assess that the technical feasibility of the Microsoft SQL Server-based project is much better than the other two. Oracle is arguably close, but still not great, right? So really, that would have the best weight on technical feasibility. But there could be other factors too, right? So there could be, maybe the Microsoft SQL project uses Microsoft's Internet Information Services as its web server, but maybe my team knows Apache much better, which is a different web server. So then that would kind of flip that around. And then what I'd have to do is weight those two to see which one's more important to me. Is it more important that they understand the database engine and they can figure out the other stuff, or is it more important they know the web server software and they can figure out the database engine, right? So I have to figure out which one of these is more complex. And again, this is where that experience comes into play for a systems analyst, how they're evaluating these. But this is certainly something you would look at as far as the appropriateness of a project. So the potential consequences of not assessing and managing risks with technical feasibility could be failure to attain expected benefits, inaccurate project cost estimates because of extra training that's needed and things like that, maybe extra licensing that you weren't aware of, inaccurate project duration estimates because they have to learn these technologies, maybe we have to build technologies to fit our needs, failure to achieve adequate system performance levels because maybe the alternative that we chose from a technical perspective is not, it doesn't have the capability. Go back to my previous example of database engines. Microsoft SQL Server is a great database engine. It's very capable, and it's, there's a lot of great reasons to use it. Mongo or Couch, which is a hierarchical database engine, is much faster. There's things that it's not as good at, but it's definitely a lot faster. And maybe I'm dealing with a project with a tremendous amount of data, and it's gonna outpace the technical capabilities of Microsoft SQL Server in performance. Maybe the data is going to be accurate and all that, but I'm going to lose that performance factor. So that's another place where I'd have to assess the feasibility. Can Microsoft SQL Server keep up with, to a reasonable degree, keep up with the performance needs of this project? Maybe I have to go to a different engine like Mongo or Couch because I'm more confident in its ability to perform. Failure to adequately integrate the new system with existing hardware, and so forth. There could be some other procedures and processes and things that we have to take into account for technical feasibility. So some other risk factors: project size, the team size, organizational departments, project duration, programming effort, the structure, new versus renovated system, development group, familiarity with the platform, software, development method, a lot of things I just talked about. The user group, do they have a familiarity with the development process? Are they going to be able to learn and understand, from a technical perspective, will they be able to use this system? What type of platforms do they need to be able to use it from? What are their computers going to look like? Do I have a system that has client-side components that will require a video card that, you can't just buy off the shelf? So 4 general rules of assessing this risk. Larger projects are riskier than smaller ones because there's a much larger outlay of cash, which relates back to our financial feasibility analysis. A system which requires, in which the requirements are easily obtained and highly structured will be less risky than ones that's messy or ill-structured, ill-defined, or subject to judgment of an individual. In other words, if there's a prepackaged software that's available, that's going to be less risky than building something that we don't fully understand. The development of the system employing commonly used or standard technology is going to be less risky than employing novel or non-structured non-standard technology. And 4, a project is less risky when the user group is familiar with the system's development process and application area rather than unfamiliar. So some of the risk factors here. All right, so here we go. This is just a matrix of these different risk factors from Modern Systems Analysis and Design by Valachik and George, 8th edition. So some other feasibility concerns. We have operational feasibility. Does the proposed system solve the problem? Does it take advantage of all the available opportunities? We have scheduling feasibility. Do we have the time to complete this, right? Do we have the bandwidth? Are there any other large projects that are happening that will, maybe one alternative is going to be much more time, but use a lot more of our time than, say, another project. There's legal and contractual concerns. What are the legal and contractual ramifications of the proposed system? Political concerns. How do the key stakeholders view these different alternatives? So if one of the stakeholders, is not going to accept one of the alternatives for some variety of reasons, and a lot of times the reasons are dumb, right? It could just be that I hate Microsoft, right? Maybe we should avoid a Microsoft solution if one of our, key stakeholders, just for whatever, illogical reason. I mean, look, I complain about Microsoft as much as the next guy, but if they have a decent solution that meets my needs, there's no reason to discount it. But some people just don't like Microsoft. You might have somebody that says, I don't like open source. We're not going to use open source. I don't like it. Maybe you got a manager that, or the CEO just says, I don't trust open source. We're not using that. That would be a political concern. All right, I'll pause here, and then we'll pick up with the building the baseline project plan in the next video.